IDS technology is founded in 2006. IDS is serving worldwide more than 40 partners. The main task of the company is the continuous development and sales of its registered product, Econ SI. Econ SI means Energy Contact Solution Integrated. Econ SI is developed to make from each kind of switchgear a fully withdrawable system at highest level of safety and availability. The product Econ SI is basically consisting of three components, which are the contacting module, the busbar module and the cable module. The contacting module. The contacting module has all functions of a conventional drawer and goes up to 630 amps. There's only one size up to 315 amps. Imagine the advantages in engineering, saving a lot of mechanical parts and saving costs. The busbar module. The busbar module takes flat standard bus bars up to 60 mm by 10 mm. Optional, also up to 200 mm by 10 mm. The busbar module realizes full insulation of the vertical bus bars from face to face as well as from face to earth. Modular construction allows easy installation without the need of any tools. The busbar modules allow connection to the contacting module every 75 mm. Shutters cover the busbar where no access is needed. Wherever access is needed, movable operating shutters are installed. The cable module. The cable module has a nominal current of 315 amps. Two of them, in parallel, reach 630 amps. The cable module is dimensioned to screw cable up to 75 square millimeter. Special executions take cables up to 240 square millimeters. Standard cable connection with cover up to 75 square millimeter is foreseen to realize up to Form 4B. Bigger cable dimension needs customer-specific construction and covers. The picture is showing samples how a cable connection can be realized. The drawer shown here is only 450 mm wide and 75 mm high. The drawer is equipped with electrical switching devices for a motor starter up to 22 kW. This demonstrates an extremely compact and space-effective sample. The drawer is located in its drawer compartment, what will be visible when the drawer is pulled out. The operating window at the front shows the label green, which means the drawer is in disconnected position. It is disconnected from power side as well as from control side. Lifting the mechanical fixing knob at the right allows now to pull the drawer out. The drawer compartment consisting of drawer bottom with the pre-installed cable module, busbar module and female of the control plug remain at their position. Queen guide at the left side of the drawer compartment helps to find easily the slot to insert the drawer. The contacting module moves like being installed on rails and is catching its counterparts to bring the drawer in the right position for the test or operate. During inserting the drawer, the protecting shutter is opened and will be automatically closed again when pulling the drawer out. The complete functionality of a conventional drawer is solved by the contacting module itself. This can be demonstrated with the contacting module and cable module without any additional mechanics around. The contacting module carries the contacting bolts for power in up to 4 poles and the same for power out. It has a mechanical slide to install the control plugs up to 48 pins from each kind of brand. In the front it has the mechanical interlocking and operating holes to drive the gear. To move to operate position. Starting at disconnected position, showing label green. Insert the operating key with its nose at 12 o'clock into the hole on the right. Push the key and turn right until reaching the end position. As you can see here, the control plug and the contacting bolts are moved out. The window indicates fully red. The big advantage is that we can move to operate position without wrecking the drawer and without moving connected power cables. To move to test position. Starting at disconnected position, showing label green. Insert the operating key with its nose at 12 o'clock into the hole at left. Push the key and turn right until reaching the end position. As you can see, only the control plug is moved out. The window indicates fully blue. Going back to disconnected position. Starting at connected position, showing label red. Insert the operating key with its nose at 5 o'clock. Push it and turn left until reaching the end position. As you can see here, the control plug and the contacting bolts are moved back. And the window indicates fully green label. Operating position will be reached by turning the shaft, carrying the contacting bolts, which are getting a huge contact pressure when reaching and pressing the opposite cable or busbar module. This connecting technology is based on flexible pressure contacts. This can be followed up very well when the cable module is pushed in its position and turning the shaft again. In this position, the high contacting pressure can be demonstrated.
The turnable, spring-loaded and flexible contacting bolts press each other between the contacting module and cable module, respectively the busbar module, keeping all the contacting forces within the system itself.
This demonstration shows, as explained before, that the system Econ itself represents in its functions a completed drawer, and additional metal sheets have only the function for carrying the electrical components. To explain the pressure contact principle, watch the following integrated video. The video shows the connecting and disconnecting of the pressure contact. The braking is done on both sides. It's a rotary-based double braking. The contacting bolt slides with a hard pressure over the contacting areas at opposite side and works self-cleaning. The strong flat spring together with the high flexible copper layer take care about an optimal pressure force at any time. The anti-parallel flow of the current through the U-shaped copper layer reinforces the contact pressure in case of a short circuit caused by the electromagnetic field generated within the U-shape. By turning the operating key by 10 to 15 degrees to left and right and doing this several times, the contacting bolt starts to rotate axially. It is realized in this way to break up a small welding point, what might be caused by an overload, before the bolt is turned back to disconnected position. To repeat these steps again with the completed drawer, we'll explain the mechanical interlocks. The operating holes are normally closed by a movable latch. The operating holes can be opened by pulling the operating latch to the left. The operating latch is interconnected with the high flexible ELD, easy locking device, which is blocking the operating latch when the MCCB is switched on, because it's only allowed to operate the contacting module when the MCCB is switched off or the drawer is de-energized. There is also a small slot to place a pushing knob to check if the operating door is closed before energizing the drawer. As an option, there can also be installed a mechanical coding device, which can carry 1000 different mechanical addresses. The three parts, contacting module, busbar module and cable module, together they form up a hermetic encapsulation. Prevention means that the contacting device, the vertical bus section and the outgoing plug make up a fully insulated whole, thus achieving an arc fault-free zone. The cable module is installed in line with the busbar module. Together they realize a guiding rail to insert a drawer unit. All electrical power contacts and mechanical functions of a drawer, including its interlocks, are realized in the contacting module itself. Additional metal sheets are only used to carry the electrical components. The EST wall is of high importance and is responsible to put the Econ SI elements in the right position and strictly in line. The EST wall, energy and signal transfer wall, has to be installed and aligned in such a way that the cable module and busbar module are mounted absolutely in line. Note that compared to competitive system, the VBB is located at the side and not anymore at the back. This side wall, called EST wall, is the absolute central part and makes the switchboards based on the technology so flexible. Wherever the EST wall will be installed, it is dividing the switchboard in drawer compartment and cable compartment. Furthermore, the EST wall is prefabricated in steps of 75 mm, alternative 100 mm. This makes changes and modifications to be easily realized. The components belonging to the EST wall can be mounted easily without tools or screwing. The push-in and drop technology gives a strong short circuit withstand up to 80 kA per segment, optional 100 kA for the VBBs. Necessary blind shutter and operating shutter make the whole to a fully insulated, non-touchable vertical bus section. The production of the EST wall will be in your hands. The EST wall can be manufactured by 1, 2 or 3 pieces, depending on bending machines. So how do the units work together? Cable module, as we see it here, busbar module, together with a combined shutter system and a contacting module. You can insert it as demonstrated here. Together, these three parts form up a completed closed system. We call it also an arc fault-free zone. At the final stage, When we push in the drawer now, the shutter system will be opened and will be closed again by pushing back. This is a function you can repeat 1,000 of times without any difficulties.